All right, welcome back. So now that we've discussed what the ratio test is and its results here, that if the ratio, the uh, limit of the ratio goes to a number between 0 and 1, we say it converges. Goes to something greater than 1, we say it diverges. And it turns out if r is equal to 1, the test is actually inconclusive. Okay. So we want to use the ratio test to determine if the series converges. So what we do is we construct the ratio. Now the ratio test says absolute value, but if we're dealing with a underlying sequence where the terms are positive anyway, then we don't really need to write out the absolute value. Okay. So what I'm going to do is first compute the ratio, ak plus 1 over ak. Once I have that down to something nice, then I'll talk about its limit. So ak plus 1 over ak. Well, we plug k plus 1 in for k. That would give us k plus 1 squared over 2 to the k plus 1 divided by k squared over 2 to the k. Okay? And then we just want to simplify this. So it's this thing divided by this thing. So that would be the same as the numerator, that fraction, times the reciprocal of the denominator. So what that's going to give me is a 2 to the k will come up top to join by k plus 1 squared. The k squared will join the 2 to the k plus 1 in the bottom. And then we want to simplify this. So kind of going off to the side here just for a second, 2 to the k over 2 to the k plus 1. Remember, by properties of exponents, 2 to the k plus 1 is 2 to the k times 2 to the first. So those 2 to the k's cancel out, and so that's just going to be 1/2 that part. So our overall sequence will simplify down to be k plus 1 squared over 2k squared. Okay, so that's my ak plus 1 over ak, or absolute value. But since everything's positive here, I'm not worried about throwing the absolute value in there. Okay, so we have k plus 1 squared over 2k squared. And now we just want to take the limit of that thing. So the limit as k goes to infinity. K plus 1 squared, we can expand that to be k squared plus 2k plus 1 all over 2k squared. And then we want to work out this limit of this rational function. So we could use L'Hopital's rule, but it's actually easier to just recognize that all that's going to matter in the top and bottom is the largest power. That's going to dominate everything. So this would be the limit of k squared over 2k squared. K squareds will cancel out, and we get that the limit is 1/2. So as k goes to infinity, the ratio of the terms of the sequence approaches 1/2. The ratio of the terms of the sequence approaches 1/2. Since that is less than 1, we know that this series is going to converge. Right. So it turns out the series k squared over 2 to the k, as k goes from 1 to infinity, is actually going to converge. Now, what in the world it converges to, I don't know. But we do know it does converge. We do know that it does converge.